Okay, so first thing, we're going to go ahead and on your calculator, we're going to go ahead and graph 1 over x squared. Okay, so when you graph it, it looks like this. So what we're going to do is we're going to go ahead and draw in the asymptotes. And this one actually has asymptotes the same way the other one did that we looked at on the notes. So the number on the bottom tells you if there's a vertical asymptote or not, and so there is a vertical asymptote at 0. So that x was all by itself, which is what makes it have an asymptote at 0. And then there is no number on the end. It would be like a +0 on the end because there's nothing there. And so that tells us there's a horizontal asymptote at 0. So when you're doing these graphs, it's a different parent graph because it says x squared instead of just x. But the asymptotes you're going to find the same way. And you're still going to find asymptotes instead of a vertex, just like we did with the other graphs. What is different between this parent graph and the other parent graph? It's only positive. So instead of the curves being in opposite corners, they're either both going to be on top or both going to be on bottom. Okay, so it's a little different that way, but other than that, everything else works about the same. So if we go ahead and graph this, I'm going to do second graph, and I'm going to look for 0 because that's where the asymptote is. And then I'm going to get a couple points to the left of that and a couple points to the right of that. And then I'll have enough to make the curve. So I've got the point -1, 1. And -2.25, and then +1, 1, and +2.25. And then we just make sure that when we draw it, we have the curve following the asymptote. Okay, so let's go ahead and flip it over. We'll do the example that has more stuff going on. So if we look at this, then what is the vertical asymptote? -2 or +2? +2. You always do the opposite sign. So x equals +2. And then we're going to go ahead and draw that vertical line at +2. And then what's the horizontal asymptote? 4. So horizontal, y equals 4. Okay, so let's go ahead and write down what the transformations are. We have a negative in the front. Reflect over the x-axis. What about this part inside? Right 2. And how about the number on the end? Up 4. Okay, so there's our transformations. Since this is reflected over x, that means instead of the two curves being above the horizontal asymptote, instead of being above, they're going to be below. They're going to have reflected down. So let's go ahead and graph this. So -1 divided by, and then we're going to put x minus 2 in parentheses squared with a +4 on the end. Yeah. I think I mentioned in the video not to do that, but I don't think I ever showed you guys why. So I'll go ahead and, so when I plug it in this way, how easy are those y coordinates going to be to graph? Miserable. So if you type it in as a fraction, it gives you your y values as fractions, and then they're harder to graph. If you type it in using division, then it will give them to you as decimals. And since we're using the calculator to graph it, that's much easier. Yeah. So it will graph it the same way, it will graph it correctly, but as far as you being able to get points to plot, that would be harder for you to get it from that version. Yeah. Okay, so we're going to graph this. What x value should I look at when I look at my table? Not 4. 2. I'm going to look for 2 on my table because that's where the asymptote is. So positive 2, and you can tell where you're looking because it gives you the error message, right? So we're looking for the asymptote, and then we're going to go a little bit to the left of the asymptote, a little bit to the right of the asymptote, and that will tell us what points we need. So I need the point 1, 3, and then 0, 3.75, and then I need the point 3, 3, and then 4, 3.75. So what is the domain going to be for this graph? Not to 4, to 2, yep, because that's an x, your x value. So we're going to have negative infinity to 2, and that's all this stuff. Negative infinity to 2 is the left side. No, but you're close. 2 to positive infinity. Yep. So negative infinity to 2 is this curve, and then positive 2 to infinity to positive infinity is this curve, and so we're just saying that we need all the x values, but we're skipping 2. That's what that says. Okay, how about the range? No, it wouldn't use 2 because that's an x value. We're going to use 4. And is it everything above 4 or everything below 4? Below. So we're going to say negative infinity up to 4, and that's it. All right, how many x-intercepts are we going to have? 2, yeah, do you see it? Because it's gonna cross right here, and it's gonna cross right there. So we're gonna have one x-intercept that's slightly less than 2, one x-intercept that's slightly more than 2. So go ahead and hit, to get back to your screen, I'm gonna show you guys a little trick that is nice when you're feeling lazy and you don't wanna scroll left and scroll right. So if you hit second trace, we know that the x-intercept is somewhere between 1 and 2, right? One of them's between 1 and 2, the other one's between 2 and 3. So I'm going to hit number 2 just like normal to find my x-intercept. But when it says left bound, instead of hitting the arrow and scrolling, I'm just going to type 1. And then press enter. And then for right bound, instead of scrolling, I'm going to press 2. And press enter. And we always ignore the guess because it's always stupid. Press enter one more time. 1.5. So you can do that instead of scrolling back and forth. If you can tell what numbers it's between, you can just type those numbers in and it will go directly to it. So for the other x-intercept, we're going to do second trace number 2, and this time for left bound we're going to type 2, and for right bound we're going to type 3, and we're going to ignore the guess again, and we get 2.5. Do you guys remember how to get y-intercepts? Second trace 1, plug in 0, 3.75. Is there a max or a min? Nope. Okay, let's go ahead and do increasing and decreasing. So if I write my stick figures right here, what's the x value of a left arrow? Negative infinity. And what is this stick figure doing? Decreasing. And what is the x value right here? But it's getting closer to the dotted line, right? So what was the dotted line at? 2. So we're going to say that that stick figure goes down until he falls into the abyss at 2. And then when that stick figure falls into the abyss, another stick figure gets his life force from that stick figure that just died. And he pops out of the abyss, and then we get a new stick figure right here. All right, and when this new stick figure comes out of the abyss based on the life force of the previous stick figure, what is this stick figure doing? He's going up, he's increasing. And what's the x value over here? Positive infinity. Because it would have been a 4 if we were asking for the y value, but we were asking for the x value. Okay. So the other examples that I did in the video, they had one increasing and one decreasing, or they had both increasing or both decreasing. So for this one, you're going to have one of each always, because the graph looks a little different. So for increasing, I'm going to say from 2 to infinity. And for decreasing, I'm going to say negative infinity to 2. Okay. Is the graph continuous? Can you trace it without picking up your finger? No, you definitely have to pick up your finger to hop over that asymptote. So trace it, hop over, trace it. So we're going to say no, it's not continuous. And then for end behavior, we're going to say what happens as we look to the left, what happens as we look to the right. And so what is the y value becoming as you look further and further to the left? 4. And then what is the y value becoming as you look further and further to the right? 4. So end behavior for these are 4. So this unit is interesting because this is the first time we've had the end behavior do something predictable that you could get without even looking at the graph. So whenever you have a graph like this that has a horizontal asymptote, the end behavior goes to that number of the horizontal asymptote, and you don't even need a calculator for it. You just know that's what's going to happen. So when it said 4, that plus 4 on the end, that plus 4 on the end tells you that this is going to happen. Without even going to look at a calculator, you know this is going to happen every time. Okay. How do you guys feel so far about these graphs? What's the biggest difference between these and the ones we've studied so far? You'll figure it out tomorrow? I'd say the asymptotes are different because we haven't had that before, right? Like the dotted lines. Yeah. You don't have to memorize it. You got your notes in front of you, you goob.
Yeah, but like, you think we're actually going to look at our notes over the weekend?
No, I think you have your notes in front of you right now.
Oh.
Oh, yeah, okay.